Alright, today we're going to prove that a quadrilateral is a parallelogram. So let's start with the quadrilateral here. So if I'm given that opposite sides are congruent, then the quadrilateral is a parallelogram. So if opposite sides are congruent, then it's a parallelogram. Alright, so we got a quadrilateral here, ABCD, and we're given that triangle BEC is congruent to triangle DEA. So this top triangle there is congruent to the bottom triangle here. And then we know that BC and AD are parallel. So if we know that, because those triangles are congruent, we know that AD and BC are congruent because of CPTC. CPCTC. Corresponding parts of corresponding triangles congruent. Alright, so because we know those are the same, then we also know that this angle here, angle D on ADE, would be the same as angle B, and angle C would be the same as angle A. So that would make these other angles the same as their corresponding parts. So we know that this is a parallelogram because if you know that the sides are parallel and you know that two sides are congruent, the other two sides have to be congruent as well. So we know that that's a parallelogram. And just to give a counter example, if we had two lines that were parallel, but the lines between them weren't congruent, so let's say I had that, and let's change this to that. Oh wait, nope, I didn't want to change it to that. Let's make it like this. So you can obviously see that is not the same length. Those two I just drew on the sides are not the same length. So that is not a parallelogram because my parallel lines are not congruent. Alright, so now I'm given that parallelogram MNOP with the diagonal of NP, and I need to prove that triangle OPN is congruent to triangle MNP. So first, I know that MN is parallel to OP. And I know that because I was told it was a parallelogram. So that's definition of a parallelogram. Alright, next I know that angle MNP is congruent to angle OPN, and I know that because they're alternate interior angles. Alright, next I know that NO, and my end's getting messed up there. There we go. NO is parallel to MP or PM, and I know those are parallel because, again, that's the definition of a parallelogram. Alright, so the next thing I know is that angles NPM is congruent to PNO. And I know that because those are also alternate interior angles. And then next I know that NP is congruent to NP based on the reflexive property. It's the same line, so it has to be congruent. Alright, so now I have sides are parallel, I know angles, two angles are the same, and I know a line is the same. So I can prove this, these two triangles. So triangle OPN is congruent to triangle MNP because I have an angle, I have a side, and I have an angle. So I proved it based on angle, side, angle.